Okay. Hi everyone. Today we are going to present CNC machining of carjet and the subject EMM3526 Computer Aided Engineering. We are from Group 9. Before we start, let me introduce myself. My name is Safa Akila binti Siddiq and my matric number is 197095.
Okay, my name is Amin Najmi bin Husaini. My metric number is 195921.
My name is Amiruman bin Kamsi. My metric number is 198947.
And my name is Alif Akmal bin Omar. My metric number is 198518.
Okay. So, for the objective of the experiment is to study the requirement for the design for assembly in manufacturing. Second is to analyze the manufacturing process requirement for the proposed product. Third is to verify the machining requirement for the said product. So to verify the requirement of the carjack. So we go to the next slide. Before we go through the design, let me introduce to you guys what is CNC machining. CNC machining is commonly used in manufacturing in industrial application. It is subtractive processing process that usually uses computerized control and machine tools to strip material layer from a stock piece known as the blank work piece and create a costume design component. So in this experiment, design has been conducted in CATIA V5R21 software and the design of the carjack has been selected. Carjack can be defined as mechanical lifting mechanism for the deployment of massive forces or the lifting or heavy load. So in this design, it has a consists of 6 parts. Let's go through the machine component. As you can see, okay, you can go to the next slide, please. Okay, so the machine component, we have total have 6 numbers of component. So in the figure 1, show the exposed view of the carjack. As you can see, it's a straight component. It clearly can be seen. So for the number 1 is top plate. Second number is base plate. Third is lifting arm. Fourth is slider. 5 is screw thread, and 6 is thumb bottom pin. So to assembly and complete the carjack, we have specified the quantity to assemble all these components. So quantity of top plate is 1, base plate is 1, lifting arm is 4, slider is 2, screw thread is 1, and top bottom pin is 16 pieces. So we go through the CAD modeling. Next slide, please. Okay, for the first part is top plate. This is the first component we use to complete the project. So as you can see, it has 5 views of a top plate. First is asymmetric, front view, side view, top view, and bottom view. So as you can see, we have a specified the diameter, radius, and length, height of the measurement. For the second component is base plate. Base plate is it has the same at the bottom of the base plate. So we pad the bottom of the base plate. So for the next slide please. So for the third component is a lifting arm. This component is to support the top base and the screw thread. So as you can see at the at the final of the lifting arm, both final at the lifting arm, we can see a circle which has hole to connect others component. So they have a measurement. In the slide, you have 5 views, which is isometric views, top views, side views, and top views and a front view. So at the front view, you can see it has 2 holes, and at the middle is a hole that the design of the lifting arm. Next slide, please. Okay, so for the screw thread, it has a head and the body. So for the body, I use a helix circular to make the screw shape at the body. So the diameter, the diameter is 30, and the distance between the circular is 7 millimeter. And when I pad to the 1.5 millimeter for the screw. So next slide, please. In the fifth, we have about top bottom pin. This function is to assemble all the components. As we can see, we have a diameter, we have a front view, a symmetric view, and 10 radius. So the sketch will follow by the diameter measurement of the head and the body part. The function of the pin is to connect all the components in assembly process. For the component number 6 is slider. So the center hole with a radius of 50 millimeter will create to put our screw thread inside. The screw thread use a circular helix command to make a grid shape for screw thread rotation inside the slider. The distance of the circular with each other is 7 millimeter, and pocket thickness for the circular helix is 1.5 millimeter times 1.5 millimeter in every to others members. We're going through the CNC milling.
So the next step is the CNC milling machining. So thanks so far for the present. So for the first part is the lifting arm. So this is the first part of the car jack. So next slide. Okay, for the first step, we need to make the rough stock of the object. So to doing so, we simply select the machining and advanced machining, and then I create the rough stock slightly bigger than the original stock as shown in the slide. So after that, I just select the part operation to set up the whole process. So for the first one, I choose the machine, which is milling, and then I choose the 3-axis machine. So and then I just create the 0 point, which is the corner of the rough stock. And the last two is the set up the part body and the rough stock. After that, we going to the machining operation. So for the first machining operation, which is the roughing. So for the roughing, I just choose the roughing, and then I click at the body, and then for the tools type, I choose the end milling, diameter 16. And then just press the show and run the and run the video of the simulator. So next slide, please. So after that, after the video is run, so this is the result that I get. So to make the hole, I just simply use the drilling, which is I choose the diameters 10. Then just drilling the each hole of the part of the slide of the lifting arm part. So next slide, please. So for finishing, I just use Z layer. This one because the Z layer can smooth the part of the object. So after the whole process is done, I proceed to the generate the NC code. So this one is simply select the tools option and then select the post processor, which is the IMS. So after that, right click the manufacturing program one and then simply generate the code and choose the file location of the code that we want. So the next slide. So the second part is the slider. So for the slider, I also use the same as before, which is creating the rough stock. Next slide, please. So this is same as before. Just simply select the machining, advanced machining, and create the rough stock. This one I make the stock slightly bigger than the original part. So after that, I choose the part operation one to set up the process. So this also same. I just choose the milling and the 3-axis machine. So the second one is create the 0 point. So the 0 point I also I select at the corner of the rough stock. And then just set up the part body and the stock. So after that, I proceed to the machining operation. So for the machining operation, I choose the roughing also. So for the roughing, I use the tools type, which is the diameter 16, and then just click show and run the process. So in this slide, this is the part when the object is ready to be roughing. So next slide, please. So this is the result after the roughing. So to make the hole, I also use the drilling. So the drilling tool is the diameter 16. So after that, I make the hole through until the other side, and then I just simply press the slideshow and run the video of the simulator. So the next slide, please. So after that, we get this, and then for the center of the hole, I use the drilling also, but this one I choose the diameter 30. Same process as before. Break through until the other side. So next slide, please. So for finishing, I choose the Z layer to make the part smooth. Smooth. So after the process is done, we proceed to the generate the NC code. This also is same as before. Just simply choose the post processor IMS and right click the machining operation and simply select the create the GNC code. Okay, I think that's all from me. I'll pass up to the another presenter. Thank you.
Thank you, Najmi, for the presentation. Okay, so next for the part nut and screw machining, which is for the nut and the screw. We basically we use the same type of machining, which is for the complete machining. We need to have both machining for we need to have the milling for the head of the nut or the screw, And we also need to have the lathe machining for the shaft. Okay. Okay, so for the first step, we design a rough stock, and we need to have two stock, which is for the shaft and also for the head. Okay, so we adjust the transparency of the stock for about 166 um, to make sure that we can see the part body clear. Okay, so next we go to the machining part and we choose the lathe machining, and then we click at the part operation and we choose the machine, and the machine that we have choose is the horizontal lathe machine. Okay, so after that we choose the axis for the at the part of body, and also after we have choose the axis, we select the body part and also the stock part. Okay, so after that we choose the rough turning operation. Okay, so after we select the rough turning, we need to choose the part body and stock, the boundary of part body and also the boundary of the stock. Okay, so next after that, we choose to we choose the diamond insert. Okay, so after that, we can run the simulation. Okay, so this is the part body result after the lathe machining operation. Okay, so I think that's all from me. I will pass it to the next presenter.
Okay, thank you, Iman. So the next part, for the part 5, we will look into the part of the top plate and also base plate. Basically, for this part is quite similar to what we have been discussed or explained by Amirul Iman and also Amin Najmi. On part 5, we will also use the milling process for after the design process. So the first diagram you can see is the design part of the car jack top, and then firstly we make the rough stock of the design, same as explanation from Najmi just now. Next, after that we selected roughing from the machining operation tools. This is state when the object is ready to be roughing. Actually we can setting the roughing sizing. We want it to be smaller or bigger. After the milling process video, we will get this kinds of the shape. Next. So the last one, if you can see the top plate and also the base plate, we have two holes at the top and the base plate. So this operation of the milling part, to make it smooth, we choose Z layer. For the hole, we use the operation drilling, just like we have explained before. We use drilling to make the hole. In order for the hole to break through until at the end of the layer, we need to increase the breakthrough value to 10 millimeter. After that, we will change the file to NC code uh, that have been explained just now by Amin Najmi also. Okay, next. Okay, so the for the last part, this is what we call it as a base plate. Basically same as the top plate. So the first diagram is the design part of the car jack base. And then first step, we need to make the rough stock of the design. So next. Okay. So after we selected roughing from the machining operation tools, this is state when the object is ready to be roughing. After that, after the mining process, we review the video, we get these kinds of the shapes. Okay, next. Okay, so basically the last one, because of the base plate also have the hole, we need to have the drilling process in order to make the hole at the base plate. So after we have made the drilling process, basically after the finishing process, after the whole process, we proceed to generate NC code as the last step. I think that's all from us for the sixth part for the project that have been given to us. Thank you. Okay, next conclusion. All right.
Okay.
Okay.
So
Okay.
regarding yes, so regarding to the CNC process, CNC machining process that has been mentioned, that's been mentioned from Alif, Najmi, and Iman. The simulation CNC machining process has been successfully applied on each part of component of the project. So the importance of CNC machine is to build more quickly and constantly product durable, which is exactly and symmetrically shaped for each component of the car jack. So the machining requirement for the domestic product, which is car jack, has been verified. So that's all for us, from us. Thank you.
Thank you, guys.
Thank you.